All right, G. Period. I wanted to run through your practice exam and kind of give you an idea of maybe some things you might want to put on your note card for the test. Remember, you are allowed a 3x5 note card front and back. It has to be all handwritten, and you can't do the thing where you like write a bunch of stuff in note paper and like shrink it down and stick it to the card. It has to be the thing you write yourself, etc., etc., etc. So, forgive my speed, but I just want to jump in and kind of get started on this. So, first thing I want to say is you will be getting this cover sheet with all these delicious formulas on there. Some of these you're not even going to use. Like, we're not even using SOHCAHTOA. I don't think we'll be doing a lot with Pythagoras, but it's good to know the slope. It's good to have a circle formula, maybe an area formula since you're doing displacement as area under the velocity graph. We've got your constant velocity stuff and your constant acceleration formulas, and we're going to take g as positive 10 throughout the test. All right, so jumping into problem number 1, I do want to review some things. So starting with section number 1, or problem number 1, section 1, the question we want to answer is, which object is going faster at time equals 0, A or B? One thing I want to say, this at time equals 0 seconds, that's actually a distractor. All you need to do is look at the slope, and you'll see that A is going faster. And that's actually one of the first things you want in your index cards, the first set of things you'd want to put in your index cards. So these are things I would put in my card. So for a position graph, and be careful that you label that, the slope tells you the velocity, and steeper slope means faster, and the corollary, flatter slope means slower. So that's kind of your first little note card point. And I don't know how I'm going to mark these. Maybe I'll put like little stars by these. That'll be helpful. Just to kind of, oh my gosh, here, I'm a hot mess this morning. All right, I'm going to put a little star here just to let you know that you should put that in your index card. All right, now it says prove your answer by getting the velocity of each object. So remember, slope equals velocity. So what I'm going to actually do here is I'm going to do the rise over run for each. So just to be super careful, I'm going to take a look at object A. So I notice here this point is 8, 18. And this point here is 0, 2. So working with that, the velocity of object A is going to be that rise over run, which is going to be 18 minus 2 over 8 minus 0. That ends up being 16 over 8, which is 2 meters per second. Similarly, I'm going to do a calculation like that for object B. So this point here is 0, 10. And again, this point remains 8, 18. And now we're going to go ahead and get the slope of object B. That's going to be 18 minus 0 and 8 minus 0. Is that correct? Let me double check that. No, 18 minus 10 and 8 minus 0. That gives me 8 over 8, which is 1 meter per second. All right, so that clearly shows me that A is in fact faster than B. Now, what is happening to objects A and B at 8 seconds? What's happening is A catches up to B. Or you could say this. You could say they meet. One thing that is not true, and I just want to be clear, I'm going to write this here, they don't have equal speeds or velocities, just to be clear. Now, we want to plot the slope of each object in the graph below. I'm going to zoom out just a little bit so we can see this. So I've got a slope of 2 and a slope of 1. So I'm going to plot VA's slope right here. You notice I have a value of 2, so I just plot 2 straight across. Let me do a similar thing for object B. its slope ended up being 1. So when I plot the velocity, I plot the slope like that, and that's just VB. If I were you, I might consider on my note card drawing like here's a little position graph, and I draw the line here like this, and I would just kind of say the slope equals m, and then right below it I might draw a v versus t graph, and just kind of make a note that if it's a line for the position graph, you have v equals m here as that value. And then I would make a point that this is only for constant velocity. So I'm just going to put a little star there. Maybe that's another good little thing to consider putting in your note card if you're not clear. Okay, so that is problem 1, and we'll continue problem 2 in the next video.